Okay, so now for number 2, we want to find the minimum mass that will make this to not slip. So we want to find the minimum mass that this has to be, that this object has to be, so that this won't slip down. So to solve this, what I did was use T minus mg sine theta minus ms mg cos theta and set it equal to 0. So now that we have this equation, we can plug in our numbers. So we have 20 minus m times 10, because we know that gravity is 10, sine 20, minus 0 is to 4, m times 10 cos 20 equal to 0. So now we can start solving this. So we have 20 equals m 10 sine. We took out the common m, 0.67 times 10 cos 20. So all we did was take out the common m's. Oops. So we had an m in common here, and we had an m in common here. So now we're solving for m. So basically we're dividing this by 20, not by m, sorry. So since we have a 20 here, so we're dividing this by 10 sine 20 plus 0.67 times 10 cosine 20. So we can cross this out. So basically we're going to have m is equal to 20 divided by 10 sine 20 plus 0.67 times 10. Let's do it like this. Cosine 20. So this is what we have. So if we solve, we're going to have that m is equal to, or approximately, 2.05 kilograms. So this is an approximate answer. So if we go back to the question, we'll see that the answer would be this one. So this is the minimum mass so that this object won't slip.